Hey, welcome back. This is part two of my little video series that shows the work I've done and continue to do on this project to bring my little cartoon to the Commodore 64. Now, well, part two, we are 10 days into the project now, and at this point I felt I had my video player to the point that, I could probably comfortably move on to the audio. I'm not saying the video is ready to work, it's just, okay, enough of that, let's go get some audio. Let's start fresh and fun with something new. And of course, if I couldn't get the audio to work, then there's no point in doing this at all, right? But anyway, so I re-watched Jeff Birt's videos and made new, well, not new notes, just notes. Lots of notes, because I wanted to make sure I get this right. And I followed his tips and used Audacity, and I guess, well, I guess you'll see. Remember though, because like when all's said and done, this isn't a how-to video. It's not going to show you how to do this yourself. It's more or less how I did it. And I don't always do things right, but, well, I hope you find it interesting, just like the last one, unless you thought the last one sucked. Who did thumb that down anyways? But, okay, let's get to it. And yeah, 10 days in, now let's experiment with D418 Digis. Here we go.
Starting by taking notes on Jeff Birt's Digi video. I used Audacity and, well, I created a signed file. I couldn't figure out how to get his program to even launch because I don't understand GitHub, but I brought the data in and I did some analysis on it. I made it unsigned and then I changed the batteries in my camera. So let's look again. This time I'm at 1080p, it doesn't matter. I'm going to just pause this or list it slowly. So what I did is, well, this is just my monkeying around program. I used it to switch over signed to unsigned. I counted the occurrences of each value. I also looked for the top and the bottom that were either occupied with some sort of non-zero value, and then the top and the bottom of the clumped range. That is, like if there's like 0, 0, 0, 0, 0, and then 1, 0, 2, 0, 5, 6, 9, 9, 9, 9, whatever. It gets rid of the sections that have zeros breaking them apart from the clump. Because I feel that that clumped area is the area that can be expressed. I'll list this again. The clumped area is probably the one that we want to stretch out to fill the full range. Not 0 to 255, but from 16 to 255. I haven't done that yet, but I was so eager to get this tried, I ran it. And all I heard was just a burst of static. And then I realized what I was doing, because I have this multi-routine here based on what I want to do at the moment. Whether I was going to count or get rid of the things that aren't clumped, or just get rid of the signed. I just fed them to that, and I got a big burst of static, and then I realized, well, that needs to be slower. So, well, actually, no. What I first tried is this, and I shuffled them over, and then threw it to the SID, and because like this isn't pack nibbles, this is just a full bite, and I heard something, but it was too fast to tell. So I threw in a bunch of pokey little, these slowdowns. And then, I haven't changed it since, but this is what I heard. Let me turn this up a bit. Check this out. Oh, it's glorious. And it's just the beginning. Haha, that sounds like ass, but it's my ass. Well, not my ass, but yeah. And the Super CPU is just plugged in. It's not an effect. The BackBit isn't the deal. This thing is what's working the magic. But I had to use just a 24 kilobyte file because once I got this down, then I can apply it to the entire 1 megabyte audio file that should be included with this video clip I'm working on. And yeah, boy, I got some polishing to do. This is awesome. And Jeff Birt made this possible. And I mean, yeah, like, see, there's this stuff. What else we got? There's that. I was working on that. Just, oh man, notes. I can't even flip the page. But stuff. It's awesome. And if you add a long enough delay, this is what happens. Now listen carefully with this. It's got like bad static in the clip. And I wonder if this is a good way to polish your audio, if it can play smoothly while it is so slow. Anyway, here we go. The water always tastes so good here. Yeah, so let's see here, 386, go to 395. So now we're going to skip a bunch of these, reassemble it, and now it's going to play like a super hyper chipmunk, and you might not even be able to make it out, but it'll be a higher voice. Now listen. See? Of course, well, let's add in a few more instructions in between. And there you have it. Now, what you see here is not using any interrupt at all. So I just padded it out, counted it out. This is 127 cycles, so all this gibberish in between is what my program would have to do on its own before the next interrupt hit. Here we go. And that's it. I added that because based on the fourth shift, now it's going to round certain things up. And this is just a quick trial just to see if it sounds any better or different. Here we go. You're the first time I'm hearing this too. I don't know, that sounds better to me. And what you see here is a value, the number of occurrences in my sample Digi, and then a running total of, all the bytes added together. What I did is I took low values and high values, I squished them a bit, sort of just scrunching them together, and played it again, and then I tried it again, and this is the latest. What I've done is reduced the entire Digi from values ranging from 120 to 136, and that's it. This is going to sound like crap, but oh wait, I had it still set on the count and not the play. Now, what will this sound like with such a very limited range? Can you believe that? We have a value, such a limited range of values, and yet you can still make it out. This is crazy. I'm going to squish it down to almost nothing and see what happens. Oh, one more thing. I still have my rounding doohickey in place. Let's take that out and then see what happens while you're still here. I'll just mem that out. Interesting. Okay, this is getting silly. Look at my Digi. It has 6 different values in it. That's it. Those are the values. This is how many times they appear in the file and then the current of the totals. By accident, I also left the count program or the count subroutine dropping down into the player. So the player is doing more work between sample plays, so it's a slower pitch. But you can still make it out. Check it out. Wow. With 6 different values, and that's all it's doing. And those 6, I think they're just getting whittled down to 2. I'm sure it is. I'm going to do that next. Okay, you might think I'm jerking you around now. I have reduced the entire file to 2 values, 127s and 128s. Now, just to show you, check it out. That's it. The entire Digi is these things. Okay, so let's get out of here. And yet, you can still make it out. That is crazy. That's only toggling between 2 values about 8,000 times a second. Wow. And accidentally, the 7Fs, I made them zeros just a few minutes ago. While it sounded awful, like screechier, I could still make it out. I'm just going to change those to something else. Let's see what happens. Here's the scoop. We're going to take our value, just toggle it with something, save it for next time, play it. And now I can queue up new values at will right here, and we can just listen to see what different things sound like. So switch values on this. 121. Oops, frick. Yeah. Man, I gotta get myself a tripod. Yeah. Well, those 2 values sound like crap, don't they? Well, I played with that video enough. I corrupted it completely. So I reloaded it, the signed raw file. However, I haven't normalized it yet, or whatever. You flip the high bit around. Listen to this. Oh, that is awful. See, now, there we go. Oh yeah, so I want to flip it, put it back, and still play it. Neat. But at the moment, it's still in that weird range. I got to trim the crap and stretch it back out, and that's where the magic should happen. That's the thing that Birt was trying to do with his program. Let's see if I can do it with mine.